Just wanted to do that just to
members. Welcome all people, members of IFSF. My name is Kees Maus. I'm the project manager of IFSF. This second webinar is about the forecourt database collections and on exploring accessing the dispenser API in the Open Retail GitLab repository. The presentation will be given by Gonzalo, and this webinar is only for IFSF members due to the anti-competition and IP rights on the material presented and discussed. So if you're not an IFSF member, please, or do not adhere to the IP rights, then you have to leave the meeting. Please put your questions in the chat function so that Jason can use your questions during the Q&A sessions to ask them to Gonzalo. Also, would like to remind you that on the 14th and the 15th of November, the IFSF 30 years anniversary conference will be held in Manchester. You can still register our website, www.ifsf.org. And I want to transfer now to Gonzalo, who will start the presentation.
Okay. Hi, everyone. Welcome to the new webinar. The main purpose of this session is to cover the dispenser and forecourt database. Last webinar, we covered an introduction to IFSF, its different standards and APIs. Now we will dive into the dispenser API collection and forecourt database. We will see where to access the APIs, how information is organized, and then review the available documentation for the dispenser APIs. This will include API collections documentation. And last, we will see the forecourt database that intends to provide a bridge between LON and API-based devices. First of all, let me clarify the terminology. An API, when we refer to an API, we refer to an individual API call that can be a GET to retrieve information, a POST to update data, delete to delete data, and so on. When we talk about an API collection, we refer to several APIs that are grouped into an OAS file. We use YAML format to document them. Each collection refers to a specific functionality. For example, DCA APIs are the device configuration API collections. There are also events collections and functional APIs, used, for example, to authorize a pump. API collections, in plural, refer to all the files that include the dispenser APIs. The repository will contain all the collections and its corresponding documentation. Last, each API collection includes several schemas and objects that are defined either in a schemas directory of the repository or in a data dictionary. The data dictionary is a set of common schemas used by several API collections. This makes it easier to write a more structured way and reuse common objects. But normally this is not possible to render using several of available tools, where all the objects are referenced one to each other in several files. So for this purpose, we create what is called an API collection bundle, or just we call it a bundle. And here we refer to a file where all these references are resolved within a single file. And the information in this single file format can be used by most available tools. We will see an example of this later. So back to the DSP API collections repository. To access this, you will need credentials to access the Open Retailing GitLab repository, and you can find the link, the information in the link presented here. But I'll show it to you directly on the web page. So let me find the web page. Here we have the login of the page of the GitLab repository. So this is managed by the Open Retailing team. Here what we can see is the dispenser API collection. So we have a main branch, and here what we can see are the different branches that we are being used to develop more versions. Previous versions will be tagged of an API collection will be tagged accordingly. Right now, there are no current versions. Let's do a quick browse of the different directories. The API collections. This here, what we can see are the different API collection files that, for example, we have the PDCA are the device configuration. These are the specific for fuel, and these are common, and utilities are common ones used with any other devices. The server sent event device definition YAML is a set of APIs that are used to document the events that are shared with this. Sorry. The dependencies file, here we can see this refers to which API data dictionary we're using, because data dictionaries are also versioned. So when we refer to the version 1.40, we are using a specific tag in the repository. Then also another reference is to the common forecourt database collection, that this is the schema of all the information in here. We'll see this later when we continue. So now back here, what we can see is the bundles directory, the documentation, examples, and schemas information. So examples, for example, will include the different examples that are reported in all the documentation seen before. If we go back, we can see the bundles directory. These are the same APIs that we saw before, but with the references resolved. So everything here is stored in a single file, so that it can be used by different. For example, if we use if we download the dispenser bundle, this dispenser bundle, okay, we have all the information here. We can copy and paste it. I already did this to make it easier, to an internet Swagger editor. So this, we can see here, this is exactly the same information that we have here. Here we have all the file completely resolved, and without entering into many details, we see the different APIs that are generated here. So for example, we can see fueling point information, that we'll see it later in more details, different actions and so on. But what's important is that when using this bundle and accessing, for example, this type of tools, it's very practical because developers can automatically generate a skeleton code to develop applications in most common languages, both as a server that could be for a dispenser, or client information for a controlling device that would be connecting to a dispenser. And this allows you to generate these skeleton programs and start working right away much faster. Again, this is just one of the many tools that are available in the internet. This is not let's say the only one, but it's just to show an example. So let's see now the documentation. So if we go back to the directory, here we have the documentation. The documentation has different sections, okay, including abstract, business requirements, discussion details that we're using now for hydrogen, for example, the documentation, implementation guide, and so on. These are more high-level documents, but we are going to focus in some specific ones. It will be the process flows, use cases, and the schema documentation. Here, schema documentation. These are the ones that we are going to focus. Let's start with process flows. So here, for example, we can see both the sequence diagram and the state diagram. We're going to see the sequence diagram. Here we can just download these sequence diagrams and see them in a Word. Let's open the document. And here we have it, downloaded directly from there. So here, for example, well, apart from all the introduction, what we can see is the complete, for example, how the login and initialization process flow occurs. And let's see the fuel transaction. These fuel transactions shows the different calls to the API that are done. Let me go back to the presentation where I have this with some additional details to make it clear for this. Okay, this was just, I leave it for documentation. And we can separate the process flow into several parts. First is reserving the dispenser, then authorizing the dispenser, monitoring the dispense execution, and last, tendering a sale. In this case, we're more working on a flow more oriented to the typical use cases, and it's more oriented to a prepaid, but it could be done also for postpaid, as we'll see later. The first step for a POS is to reserve the pump. For this purpose, you run a post to a fueling position to reserve, and you will be confirmed if that fueling position is available for operation. Once the POS or controlling device knows that that fueling position is locked to you, then you can secure the amount for the transaction. Once that transaction was secured, for example, with a pre-authorization from the POS, then you can run an authorized request. In this case, the authorization will also allow you to request limited with an amount, or, for example, set the approved fuel products. Once this is okay, we are looking here always at the successful transaction, so we're not looking into errors. Okay, we'll cover them later. And we will receive an event that would be a fueling state change that the fueling position is authorized. After this comes the dispense process, where the dispenser is running by itself. Here, basically, we are not looking at, we are not doing any actions, but just receiving events that where we know that for example, if the dispenser is started and the customer has left the nozzle, the dispenser is started, then we'll see when it starts fueling, that is fueling. And when the transaction finishes and hangs up the nozzle, it will be in state ready. After this, the POS can collect the transaction, okay, will receive an event of a new transaction that is ready to be tendered. By getting the transaction information, you will be able to log that transaction and tender it by running a delete. It's basically stating that it's cleared. Okay. So these use cases, okay, include, for example, reserving, authorize, dispensing, as we saw, and tendering. But by mixing these use cases, we can also work in a prepaid scenario or a postpaid scenario. In the prepaid scenario, for example, we will run what we saw before: reserve, authorize, dispense, and tender. In the postpaid scenario, what will normally occur is that the cashier initiates the transaction and authorizes the fueling point, or potentially it's automatically authorized. So the controlling device or POS executes the authorized fueling without any limits, and then the dispense occurs. Once that is completed, the tender fuel will collect the fuel information and tender the transaction. As you can see, both scenarios uses the same flows, but the use cases are different. Okay. Also, for example, exceptions are covered. Here, in these exceptions that we're covering, what we will include is more than one POS trying to reserve at the same time, multiple POS trying to suspend a fueling, or a fueling a controlling device trying to resume a fueling position suspended from another one or from another POS, and the emergency stop. Here, for example, if more than one fueling position tries to reserve, the first one will receive the OK, but the second POS will receive that the fueling position is unavailable. So that POS will know that he cannot manage that fueling position for the transaction. The same for the fueling. If you try to suspend it, the other one will not be allowed to suspend. Also, the second POS will not be allowed to resume that the fueling position, and but the first one, yes, will be able. Any device can send a delete forecourt that is basically an emergency stop that will allow to stop the complete forecourt. In the case of the dispenser, this applies both for the dispenser and for the forecourt device controller API. In the case of the dispenser, that dispenser will stop all the fueling positions of that dispenser. So you need to send a delete to each and every dispenser. In the case of forecourt device controller, the forecourt device controller will receive a single delete forecourt that will be sent to each and every dispenser at the same in a single way. So let's switch back to the documentation repository. Let me go back here, okay? And let me go back to the documentation. Here, let's see now the schema documentation. Remember, I mentioned before that we created bundles of the from the APIs that were all with all the references covered. Okay, these schema documentations, they are called redoc files because it's the tool that is used, but it's basically the same bundle that is saved in an HTML format to make it easier for anybody without any tool or without any specific knowledge of this YAML protocol to be able to read it. So let's, for example, the same document we saw before, the dispenser, let's download this one. So here we see a complete HTML file, okay, that I can download. And once it's downloaded, I can open it. I'm going to see the same as I saw in the Swagger, where I saw the database API, this one, where I saw the fueling point information, the fueling point actions. We will see them in the redoc file, in this HTML. Here, for example, we are going to see fueling point information. Here we can see how to set limits to the dispenser, how to get the state information, and different fuel modes available. Also, you can get totals and get the fueling point totals and get the display information. In the fuel point actions, for example, here we cannot see them very well, but you can run for each fueling position actions such as open, here we have it, open a fueling point. You can close it by deleting the open. You can also reserve a fueling point. You can cancel the reservation. You can authorize the fueling point. And here, for example, we can see the authorize of a fueling point, and we can see all the parameters that are used. Here in the authorization, we have a schema, and we can see all the details of what's the information that can be sent to authorize a fueling point. As I mentioned before, executing a delete of each and every action will cancel the previous post command. For example, if we run a suspend, we suspend the fueling position and delete the suspend, we'll reactivate the fueling position again. This is, for example, if also you can, another example is locking a nozzle. So for example, if a 4-core device controller detects that there is a low product on a specific tank, it will be able to lock the corresponding nozzles, and no fuel will be dispensed from that one. Okay, so here we have this. Let's see now, close here. Let's see the events. Here we have the events, okay? And here we can see is how you will be able to subscribe to events, but also we see the list of events that are available. Detailed documentation of each event and its schema is actually in the servers and events definition HTML. For the sake of time, we will not be covering this right now, but all that definition is in this information. So this mostly covers the dispenser API collection. Next, so this is the Redux that I mentioned and the events, okay? Now what we will focus is on the 4-core database IP collection. If people are familiar with legacy LON IFSF standards, you all know that LON not only provided a means to connect to the device and the underlying protocol to control them, but each device standard defined also an internal database schema that stored all the device information. For example, the dispenser had a calculator database, a fueling position database, a transactions database, and so on. And these were addressable with specific addresses. For example, if we requested the record 1, we were able to access the calculator database. If we access the record 20 plus the fueling point address, for example, 21, we will be accessing all the information for fueling position 1. Also for nozzles and for transactions. For those, and here with these communications, we were able to access all the information and also to update it. So let's say if you don't understand what LON was in that sense, for those familiar with networking, I often describe this as the SNMP or Simple Network Management Protocol, because that was a protocol capable of addressing a network device information through a specific management block database definition. So this is very similar to that, but with the LON protocol. For younger people, I describe LON as the last century IoT specification, because conceptually it's pretty similar. When we migrated the dispenser and other devices APIs, we needed a way to tap in all this information, because all this database has been updated for the last 30 years we are celebrating, and it has a wealth of information of the dispenser that includes lots of informations, including, for example, light settings at the dispenser, alarms, weights and measure information, and so on. So we needed a way to tap into this information and at the same time provide some type of both advanced data access and something that can be used to achieve some potential backward compatibility. So if I'm addressing by accessing the database one by one, this can be one-on-one converted to a LON protocol command. So the 4-core database APIs will now provide two things. A means to control the 4-core device, and also provides a means to tap into the records. As I mentioned in LON, this is also provided here. There are several specific APIs that are general for all the devices, but then you have, for each type of device, you will have a database schema that includes all the information that was completely migrated from the original LON standard. So we are keeping all the wealth of information we had there, And we are now evolving to support new features, for example, hydrogen and other alternate fuels, but again, still will reflect all the original and proven long data information. These database definitions are generated not only for dispenser, but also for price pool, ATG, and car wash. So let's see a common use case for this, okay? And then first I will show it here in the workflow, but then I will show it in practice. There are APIs that, for example, allow you to get the list of data sets. Sorry. By running a get dataset, you will get the complete list of available data sets and all its information. Then you can also get the records of a specific data set by getting for a specific data set the records. Also, once you have the records, you're able to get all the elements and its values for a specific record of that data set. And finally, by running a put command, you would be able to update them. I'm going to demo all the get information, not the actual put in this demo. So let's go now. Let me show you. Here, I will show you this by showing. I have open in background. I have the dispenser simulator open, and one of the things that the dispenser simulator offers is the complete API. It's exposing all the API collection. This is the same we saw before. For example, all the fuel point actions, such as authorize, can delete the authorize, reserve, delete the reserve, open, suspend, and so on are here. So, but now we are focusing on how to get the values of the database. First of all, we'll need to authorize the communication. So I've already included the credentials here. So I'm logged in, and this is an API key that you need to log. Then you can try, for example, and get the list of data sets. So let's try this. We can execute it from this interface. And here you will get all the different tables. Let me try to zoom it a bit so we can see it better. And these are all the data sets that are available. For example, general data, all the thresholds, display and rounding. All this information actually it was part of the calculator in the long table. So we are including also its correspondences for ease of finding. Let's go, for example, to a fueling point. So we get fueling point configuration. So we can get for a fueling point data, both the fueling point configuration and the control data. Let's see how a fueling position is configured. So now instead, let's copy this one, okay? I copy this information, and I can come now to see the records of that fueling position. So if I set try and I select the data set fueling point configuration, I will execute, and I will get that I have two fueling positions, fueling point 1 and fueling point 2. These are the record IDs for each fueling position. Here I will be able to see the elements. So if I drill down, I will be able to see the elements for this. So now I can, for example, get for that record, okay, for the fueling point configuration, and for that specific fueling point, I can get all the elements of this. So if I try this out, I can execute this, and here I'm going to get it for the fueling point configuration. For fueling position 1, I can get the name of the record, that's fueling point 1, the fueling point ID, that is 1, the quantity of unpaid transactions in the buffer. This means that for example, if I sell more than 3 transactions that are not tendered or cleared, then the dispenser will not be able to authorize any more transactions for this fueling point. Once they are tendered, they go to the buffer of historic transactions. Here it will be storing 4 historical transactions that are already tendered. Also, we can see, for example, the quantity of logical nozzles. Okay, this fueling position 1, has 3 nozzles. Then we can all that configuration of each of the nozzles, you see it in the nozzle configuration record. The fueling mode is 1, this is the price level. And 0 transaction is a specific behavior where a transaction with a null value is stored as a transaction or is not stored in the buffer. This is depending on the use case. This configuration parameter can be set to be supported by the proper controlling device. So this is an example for a complete example of how to unleash the power of the database and how this was still, let's say, all this information is already kept from old long protocol to the new APIs. This is the same information. I kept it in the presentation for documentation. And last, we can see where we can find this information. The dispenser API collection, we can find it, all the information and documentation I just presented is available to members in this URL, following this URL. And the 4-core database, and it's the documentation and the schema documentation is included in there, is found in this repository by following this link. You need to make sure, first of all, you need to request the information, the access information from admin at IFSF. So that would be Jason that would be covering this. If you need it at any moment, you request him and he can set it up for you. And also remember, as I mentioned before, that when you're looking, right now we have a single version, but we also need to make sure that is the latest branch that you are using when you access the repository to make sure that you're using the correct one. Okay, this mostly covers all the information. I don't know, any questions? Feel free to ask.
In addition to what Gonzalo said, if you do not have access yet to open retailing, then you can send an email to admin.manager@ifsf.org to get access to the open retailing website. And I don't see questions in the chat. Maybe there is somebody who wants to ask a question directly.
Gonzalo, it's Carl. First of all, thank you for that. A really excellent and insightful presentation. I appreciate that. I was just wondering, I think you said, so these are still work in progress versions. Do you know what's the sort of high level timeline for finalizing this?
Normally these are already approved, but it needs to go through some additional approvals that Connexus require in TAC to be able to be migrated to the standards directory. But this is currently a first internally approved version by the group. Normally, let me go back. I think that question raises a very good thing that I can show you here. Let me go back to all the groups, okay? Logging into the root directory. Here there are several, let's say, there are several project groups. One of them is, no, sorry, these are the groups, okay? Here what we have, for example, is all the work in progress and the final standards. Once they are standards right now, a very few has been, 4-core API collection is already published, a first version here. So we have version 1 already published. I'm normally, how can I say, accustomed to use the work in progress because we are constantly updating for the new version. But version 1 has already been published. So these are an approved version and published version for everyone.
Okay, that's great. Thanks for clarifying that.
I'm sorry. This is for core API collections. This is the FDC. Sorry, my bad. For dispensaries has not been promoted yet. That's something
Also
that
for the dispenser and the common forecourt database collections, they are in a state that they just go through some formal procedures because we're doing this jointly with Connexus to get that approved, and we expect to get the first version of that at the end of this year, beginning of next year, for those two items. And we are still working in progress on newer versions.
Yes. Yeah. The same that we have here, the forecourt API collections. If we go back to the work in progress, okay. Here we have a forecourt API collection somewhere. Here we have it, where we are working on the future versions of the forecourt API collections. Anyone that's accessing will from IFSF will have access to both the work in progress and the standards directories for all the projects.
Got it. Thanks for that.
Any other questions? Remarks?
Yes, hello. Would it be there in terms of remarks? Would it be possible to publish the redoc HTML files on the IFSF website? Because I'm thinking there is this requires browsing through the GitLab with quite an extensive folder structure. But if you just want to see the dispenser APIs, then that is actually a nice format, that redoc generated format. Would that be possible, or is that a suggestion?
It is possible. It is possible to publish the redocs, but we have to discuss internally if we only want to do that for the standards when they are our standard and not on the work in progress, because it's continuously changing. So that's what we have to discuss further internally, I think, what we want to publish on the website.
Yeah, no, sure.
Other questions, remarks?
Yeah, another question. You mentioned at the start, there's also an IFSF LON API bridge. Is that what you're about to demonstrate, or?
No. Basically, what we said is this LON database may be able to devise a LON to API bridge. It's possible. We have thought about it, but IFSF considers that this is something that is not something that to be developed by us, but it can be developed by any private company that would want to do it. But it's not. It was something that was already discussed by John a long time ago, and the conclusion was that, let's say, we are giving the elements to do it, but it's up to someone to, if they want to develop it, to do it.
Okay, so if you have an existing LON network with a database of all that information, then a forecourt controller vendor could expose these dataset APIs, or could develop these dataset APIs to expose that database information. That's the approach.
Exactly, that's the idea.
Okay.
We are exposing it here, okay, but it's not something that, how can I say? It's not something that we're not doing this sort of bridge that we have defined. If we go, for example, this is something for the next webinar, but Here you see in the dispenser simulator, you can see all the different data sets that belong to the different IFSF tables, okay? And here you can get all the different information. For example, in the controlling devices, you can see the different controlling devices that are connected. And for example, the POS or the UI, SIM-UI is this web page that is connected here. Or yes, in FP configuration, what we saw before, the same that we saw with the APIs, this is basically opening the same. We see first is the list. Here we see the different fueling points. And here we see all the information from that fueling point. Same for control data with all the information of the state of the nozzle reservation and so on.
Yeah, and that will be discussed further in webinar number 3.
Exactly.
Okay. And the dispenser simulator, can that be, in the past we had versions on the GitLab and yeah, we had versions on the GitLab. Can that be downloaded and tried out ourselves?
Yes.
We have to discuss internally how we make the dispenser simulator API available for members. We will do that the same way as for the other simulators and tools we are selling.
If you are interested in getting them, you need to contact the admin at IFSF to get them. There are specific license files that are created to be able to run the simulators.
Okay. Okay.
Okay, if there are no further questions, thank you all for attending this webinar. Also, there will be a webinar number 3, most likely to be provided before the end of this year. You will see the announcements when we plan to do that. And have a nice day. And also, this webinar is recorded and will be published on the IFSF website.
Thank you very much.
Thanks.
Thanks for attending.
Thank you.
Thank you, Gonzalo. Thank you, Case.
Bye.
Bye-bye.
Thank you all very much indeed.
Bye.
Bye.